All right, so target 1, key characteristics of functions, is the title of our lesson. So if you have questions, you can see Unit 2, Target 2, notes for definitions and other examples. Our first vocab word is domain. So just a reminder that domain is all x values. So when we're talking about domain, we are referring to our x values. So I'm going to highlight that. When we're looking at a graph, we're making a note here, and we're talking about the domain. We are looking for the left and right boundaries. We've also referred to that as our walls back in Unit 2, Target 2. So if we're looking at our domain, we're looking for our farthest left, farthest right. Those are going to be the walls. The graph will go to infinity. So graph goes to infinity when it ends with an arrow. So if you see an arrow, that graph continues to infinity. The key here to remember is that when we are writing our domain for a graph, we write it in the following way. So it's the point that's farthest to our left, and then we're going to have the inequality x, inequality, and then it's the point farthest to our right. Now, just a reminder that if the point is included, meaning maybe it's a filled in point that's farthest to our right, we're looking at these examples down below. I see this point right here is farthest to the right. That would mean that that one is also equal to. But that's what we're referring to with our domain. So all the x values, we're looking for left and right boundaries, the walls, where graph goes to infinity when it ends with an arrow. And then this is really important. I would definitely focus on this, that it's our farthest left and our farthest right. Remember, our letter that we use for domain is x, our variable. And so then we're either going to be less than or equal to or greater than or equal to. The range is all the y values. So our range is all of our y values. You want to look for bottom to top. Boundaries. And remember, we might have referred to that as our floor and our ceiling before. Our floor and our ceiling. So we're always going to put the bottom on the left-hand side. This time we use our y variable, and then the top goes on the right-hand side. Same as before, they could also be equal to depending upon if the dot or the line is filled in. So I'll just make a note of that it could look something just like that. Our examples, find the domain and range for each graph. So in example number 1, I'm going to highlight domain yellow, and I know domain is our walls. So farthest left, farthest right, and I like to go all the way through the x-axis so I can see those points and numbers. Although one thing I notice is, and this was a note we made above, that the graph goes to infinity when it ends with an arrow, and I see an arrow, and I see an arrow. So to write our domain when we have arrows on both walls is we write that as all real numbers. That's if arrows are on both walls, which I did here in yellow highlighter. My range is going to be in orange. Remember that that's the bottom and the top. So my floor and my ceiling. So remember my variable I'm going to use is y. My floor, and this is when it intersects the y axis, is 0. So that's my floor is 0. It does have a line that goes to that point, so we're going to also include that, meaning it's also equal to. So 0 is my floor, the bottom, just like we have up here in our notes.
Why is it equal to?
It's also equal to because this line touches exactly on that point. It wouldn't be equal to if it had an open circle at that point. Now our ceiling, or the top, also includes an arrow. So when we write this, we have two options on how to write this. One option is to write it exactly how it is right now and leave it as it is. The other option is to put our inequality symbol and then it's positive infinity. So I'd read that as y is less than infinity. It's not going to be equal to it. It's just going to be less than infinity. Example 2. I'm going to use the same highlighter colors. My domain is going to be yellow. Those are going to be my walls. Farthest left, farthest right. And I see that my domain, once again, the points on the farthest right and farthest left have arrows. So that tells me that it's all real numbers. Then I'm going to highlight the top and I'm going to highlight the bottom.
When doesn't it show all real numbers?
So here in our next part, when we look at the range, we see that we do have a top this time. And that top crosses at 16. It is also included. So I put it on the right hand side because that's where it's located here in our inequality. And then I see that the bottom has arrows on both sides. So when I go to write this, I would put an inequality, and since the numbers are going more and more negative, it would be negative infinity. Now, you also could just write it exactly how it's seen right now, where y is less than or equal to 16. It's up to you if you would like to include that or not. Our next example, we have the domain, farthest left, farthest right. It's our first problem where we have a dot on the farthest left point, and that point happens to be -4. It is closed. And that's farthest left, just like above in our notes. Right here. And then my farthest right point is an arrow. And it's positive. And it's going to continue. So it would also include x is less than infinity. Now, once again, just like the previous one, if you have an arrow on your boundary line that you draw, you actually technically don't have to include that, because I read this as -4 is less than x, or x is greater than -4, and that would include everything greater than -4. For our range, I'm going to go to the highest and lowest points. I see that I have a bottom that goes through 0. It is included because it's a filled in. And then my top continues on with an arrow. So I could write that with infinity. But once again, like we talked about, that's also a true statement. Y is greater than or equal to 0. And that would include everything in that problem as well. And our final example here with domain and range is, here's my walls, farthest left, farthest right. I have an open circle here, so that will not be included. So I have -3, which is the farthest left. Remember, my variable I use is x for domain. My farthest right goes through the x-axis at 1. It is a filled-in circle. So it's -3 is less than x, and x is less than or equal to 1. I do the same thing here with my range. Now here's one thing that's interesting, is I have an open circle here, but my line does touch that same point. So it will include that point. So the bottom of my graph goes through -4. It is a closed circle. My variable I use is y. It is also equal to this because this point touches that line. And the top there is 0. So our next vocab word is increasing. And increasing, the y values increase as x values increase. So you're looking at parts of graphs where you see arrows like this, or you might see curve like that. Those are both increasing parts of the graph. Now, when you're writing this, you actually kind of write these like they are the domain, the parts of the graph. So you're going to look at the walls, so make a note. And you're also thinking of it like the domain. That's how you write the increasing parts of the graph. So the y values increase as the x values increase. You're looking at the walls. It's just like the domain. Decreasing is just the opposite in terms of the y values decrease as x values increase. So our arrows are going to look, or the parts of the graph are going to be going down. Or we might have a curve down just like that. This is the same. You're looking at the walls again. And you write this just like the domain. You even use x as your variable. The relative maximum. That's a point. And you're going to write it just like x, y. Just like an ordered pair. That's a point on the graph with a y value larger than other points close by. Make a note of this. You can have more than one. You can have more than one relative maximum. So it's the point xy on the graph with a y value larger than the other points close by. You can also have more than one. The relative minimum is the point, and you write the answer the same, ordered pair, xy, on the graph. It's the point on the graph with a y value smaller than other points close by. Once again, you can have more than one. All right, so our example, identify the intervals where the graph is increasing or decreasing and list any relative max or min. So I'm going to pick a new color. I'm going to pick green, and I'm going to highlight the part that's increasing. I see that that is going up just like my y values are increasing as my x values increase. So I'm going to go over here, and I'm going to write the word increase. And like I said above, this is when I'm looking like at the walls for when that range is kind of happening. And I see that right here that has an arrow and it's in the negative, so it's negative infinity. And I write this just like I did with like domain. It won't be equal to because those points will not be included. And it keeps increasing until my x value is 1. Then I look at my graph and I see that it starts decreasing. And I'm going to highlight that pink. So my increasing was green. My decrease is going to be pink. And it starts decreasing from that x value of 1. I put my x there. And it also has an arrow. But this time it's positive, so it's going to be positive infinity. So it starts decreasing from 1 until infinity. And then I notice that this has a maximum. That's a point on the graph with a y value larger than other points right here. I have one maximum.
Can you update this from down?
Yeah, it decreased. Remember, I'm looking at it like walls. So I'm looking at it from 1. So it starts here on my x. I'm looking for my x.
Okay.
And then my maximum is this point on the graph. And that point is over 1 on the x. And it's up 3. So the point is 1, 3 as my maximum point. And then I look at my next graph, and it kind of does the opposite movement of my previous one. So here's where it starts increasing, which is green still. And here's where it's decreasing. So I see increase. And it's increasing from, on my x value of 3, and it has an arrow, so it's going to go to infinity. And it's positive. It's going to decrease from, once again, I have an arrow, and that's in the negative, so it's negative infinity. And it keeps decreasing until it gets to 3. This one has a minimum point, which is a point on the graph with y values smaller than the other points. So I have a minimum, and that minimum point is over 3 on the x, and it's up 1. So my ordered pair is 3, 1. Our last problem, we see that it is increasing, and then it looks like it starts decreasing, and then it increases again. So we have 2 parts in our graph where it's increasing. So it looks like it's increasing, and I'm looking on my walls of it, which would be -7. And then my x, and it stops increasing at -3. And then I can see it starts increasing again at +3. And it continues to increase on my walls up until 7. So those are the spots, the 2 spots on my graph. Remember, you can have multiple spots where it's increasing. Then I see it's decreasing right in between when it's increasing. And it's decreasing from -3. Remember, right here on my wall, -3. It keeps decreasing until it gets to +3. So this is the point in the graph when it's decreasing. This one has 2 minimums. We have a minimum right here, and we have a minimum right here. So we have 2 minimums. I'll draw an arrow to both those spots. This point is -7, -225. And I have another minimum right here, which is at +3 and -50. And then I also have 2 maximums. I have one here, and I have one right here. My maximum points are negative 350. And I have this point, which is also maximum, which is 7,150. So those are the answers to those examples.